Hi everyone, you're welcome to Physics Class Online. Kindly subscribe to this YouTube channel and make sure you like the button, hit the like button and comment in the comment section. If you have any question, you can just drop your question in the comment section. Thank you for watching this video. Thanks and God bless you. Today we'll be looking at the application of velocity time graph. So today we'll be using the three charts that we studied last class, and we'll be using those charts to solve equations or of uniformly accelerated bodies. We'll be solving them using velocity time graph. Uh, we said that there are three charts. So let's quickly go through those three charts as mentioned in the previous class. Then we have this first chart illustrating acceleration of a body. So when the body is accelerating from rest, we have this chart. Then number two, we have a chart of a body performing uniform velocity. That is, this body is neither accelerating nor decelerating. Then we have the third chart showing a body that decelerates back to rest, starting from higher velocity of 20 meter per second and decelerate back to 0 meter per second in time 10 seconds. So this body decelerates. So this is a graph to illustrate a body that's decelerating. So we are going to use the combination of these three graphs to solve some questions. So I want you to just follow the class as I explain how we'll be applying these three charts in order to solve some equations of uniformly accelerated bodies. So please don't forget to subscribe to this channel. Thanks for watching this class. So let's go to class and let me show you how we apply these three concepts. Let's look at this example. A car starts from rest and decelerates and accelerates uniformly for 5 seconds until it attains a velocity of 30 meters per second. It then travels with a uniform velocity for 15 seconds before decelerating uniformly to rest in 10 seconds. So sketch the graph of the motion. Number two, calculate acceleration during the first 5 seconds. Number three, calculate the deceleration during the last 10 seconds. And number four, calculate the total distance covered. Alright, let's quickly apply the concept of the velocity time graph. In the last class we said we have three charts, three diagrams that we use in representing velocity time graph, and those graph is what we are going to use in order to solve these questions. So let's look at it. So let's draw the velocity time graph. So the axis for the velocity and the axis for the time. So the V is in meter per seconds, and then we have the axis of time, and the time is in seconds. So let's look at how the body moves. Now the body starts from rest and accelerates uniformly for 5 seconds. So acceleration is shown by a straight line that starts from rest. So because it starts from rest, from this origin, it accelerates. And because the acceleration is 5 seconds, so let's just trace it down. And let's say from here now to here now is 5 seconds. That's 5 seconds. Remember, this is the axis for seconds. The axis for time is in seconds, so 5 seconds. And the question states that it attains a velocity. So as it is increasing, it attains certain velocity. Let's trace the velocity down here, and the velocity is 30 meter per second. So this axis is the axis from 0 here, and the axis goes up till it reaches 30 meter per second. It then travels uniformly for 15 seconds. So uniform velocity is shown by an horizontal line that's parallel like this, and then you are told that it's for 15 seconds. So it means from here to here is 15 seconds. So if I count from here to here is 5, and if from here to here is 15 seconds, then it means from here to here is 20. So that if I say 20 minus 5 is going to give me the space of time between these 2 points. And the question is 15 seconds. So between here and here is 15 seconds. Alright, let's continue with the sketch. Then before decelerating uniformly to rest, so the body from here now decelerate back to rest. So when decelerate back to rest, in how many seconds? In 10 seconds. So it means from here to here is 10 seconds. If I want to put that, I'll put 30 here. So putting 30 here is telling me that from here to here is 10 seconds. I see 30 minus 20 is going to give me 10 seconds. So we can use that method to number this axis. Otherwise, we can also say from here to here is 5 seconds. From here to here is 15 seconds. And we can also say from here to here is 10 seconds. So we can use any of that method to draw the chart. From here to here is 5, from here to here is 15, and from here to here is 10. So if I look at it on a straight line, we are going to have 5, then 15 plus 5, you're going to get 20, plus this 10, we are going to get the 30. So that is question number 1, which we are asked to do. That is, sketch the graph of the motion. Now let's look at number 2. Calculate acceleration during the first 5 seconds. So during the first 5 seconds, we want to calculate the acceleration. And during the acceleration, we want to pick parameters around this point. And our parameters around this point is parameters of, we have u. We want to pick it, we say u is 0. If we want to take this v, the final velocity at that point is 30 meters per second. We want to take the time at that point. Our time at that point is 5 seconds. So let's take acceleration. The acceleration is unknown. So if we want to use acceleration formula now, we are going to say acceleration is just change in velocity over time. So putting it properly, we can just say acceleration is just v minus u over t. So let's substitute now. We say acceleration is going to be 30 minus 0 over 5. So we are going to have acceleration is going to be 30 divided by 5. So acceleration is going to be 6 meters per second square. Do you see how we use velocity time graph to solve some questions involving equation of motion on a straight line? Now, number 2, we are now asked to find the deceleration during the last 10 seconds. Okay, let me just clean this side and to find deceleration during the last 10 seconds and see how we are going to analyze that also. Okay, now from our previous explanation, now we have gotten our acceleration to be 6 meters per second square. Now let's look at the next thing. Now we want to look at deceleration during the last 10 seconds. Now deceleration is talking about the body coming from higher velocity and going to the lower velocity. So in this point, our initial velocity when the body is decelerating, that is starting from this point, and if I trace on the velocity time graph, you discover that it's 30. So our u is 30, and the body decelerates until it gets to rest. Our final velocity is 0, and here we are looking for our a, which is our retardation, that is the slope of this axis. Remember, this axis is a negative slope because the way it comes down is a negative slope. And what is our time? If you remember, during deceleration, our time is 10 seconds. So let's apply equation of motion as we usually do that. So we are still going to have our acceleration is change in velocity. And remember, at this point now, it's going to be, still also be v minus u over t. So our acceleration is going to be our v is 0 minus our u. Our u is 30, and now our time is 10. So definitely our acceleration is going to be minus 30 over 10. So our acceleration at this point is going to be minus 3 meter per second square. So if our acceleration is minus 3 meter per second square, this negative does not say that the result is negative value, but a negative acceleration is indicating direction, that is indicating deceleration. Therefore, our deceleration now is going to be 3 meter per second square. So I believe you understand that. So let's look at the last one, which is determining the total distance covered. Okay, now to determine the total distance covered. Now if you look at it, I said in the previous class that the total distance covered is simply the area under this graph. So if you look at it, the whole shape of this graph has formed what we call a trapezium. So calculating the area of a trapezium will give you the total distance covered by this body. And for a trapezium, we have S of a trapezium equals to 1 over 2 into bracket A plus B close bracket H. Alright, if we want to look into that, what's our A? Remember in previous classes, for a trapezium, the A and B are the parallel sides. So look at this trapezium. This side and this side, they are the parallel sides of a trapezium. So parallel sides are two lines that can never meet. So if I extend this line and extend it, they can never meet. So the parallel lines, the first parallel lines is from here to here, while the second parallel line starts from here and it ends here. So let's take our A now from that parameters. Our A, which is the parallel lines A, from here to here, if I trace it down from 5 to 20. So if I look at the gap here, then I can say that is 15. So let's look at our B. The second parallel line is from here to here, and from here to here is 30. So our B is 30. And what is our height? Our height is perpendicular distance between the parallel lines. So from here to here is our height. If I trace it up here and measure it, see that our height is 30 also. See, from here to here is our A, so we trace it down. That is going to be 15. From here to here is our B, trace it down, it's 30. And from here to here is 30. See, it's 30 on that line. So let's now apply it into this formula. We are going to have S equals to 1 over 2 into bracket 15 plus 30 into bracket 30 into bracket 30. So let's substitute and solve it. That is 1 over 2 into bracket 45 into bracket 30. So 2 cancel this one. We are going to have 15. So S is going to be, 2 in 30. 2 here 1, 2 in 30 is going to give you 15. So we are left with 45. Then multiply by 15. And therefore, our distance covered, we multiply that, is going to give me 675 meter. So therefore, we can now say that the distance covered by this body is 675 meter. Okay, let's look at another example. In the previous class, we looked at one example applying velocity time graph. Today, we want to continue with that class and probably conclude with this example because it is the same concept we are still going to apply in solving questions involving velocity time graph. All right, let's look at this. A body at rest is given an initial acceleration of 6 meters per second square. So let's draw the velocity time graph and proceed with that motion as this particular object is moving. So let's look at it. So that's the velocity. This is the axis of velocity. So let's look at V in meter per seconds, and then this is the axis of time. Time is seconds. So let's look at what the body does now. The body at rest. So the body is at rest and given an acceleration. So the first thing is that the body first accelerates at rest. Now after acceleration, the acceleration is 6 meters per second square. So the acceleration is 6. So 6 meters per second square. Meter per second square. See where I put the 6. Alright, for 20 seconds. So let's trace it down. So here is 20 seconds. That is from here to here is 20 seconds. Alright, now after which the acceleration is reduced. Now it is still acceleration, just that it is reduced. So initially it was a straight line like this, and when it reduces like this. So acceleration is reduced for 4, that is 4 meter per second square. Alright, you discover that initially it attained one velocity, which is v1, and now when it is reduced, it attains another velocity, which I'm going to call v2. Let me clean this so that you can see that properly, which is called v2. Don't forget, this is the axis of our velocity, meter per seconds. So we have the first velocity attained, v1. Then after velocity, acceleration is reduced, we have another velocity, v2. Alright, and when it was reduced to 4 for the next 10 seconds, so it takes 10 seconds and take it down. So from here to here is another 10 seconds. It takes 10 seconds to do that. Then after that, the body maintained the speed for 30 seconds. Maintain means you draw a parallel line. You maintain the speed for how many seconds? For 30 seconds. So from here to here is 30 seconds. Alright, the next thing is we are now going to do what? Alright, so the next thing is sketch the velocity time graph. So with what we have here, we have already sketched the velocity time graph. Let me make it straight. So we have sketched the velocity time graph of that body. Now let's look at number 2. Calculate the maximum speed attained. You will observe that when the body starts from here, it attains from one velocity, and when it moves up, it attains another velocity. So what we are going to do is that if we want to determine from here to here, parameters is complete. So from here, the body starts from rest. This is 0. You start from rest, accelerate to this point, attain this first velocity. Now from here, it moves from here to this point, attain the second velocity. So we are looking at this second velocity. So the first thing we are going to do is, before we attain this first velocity, we need to first determine this first velocity. That is, this v1 needs to be determined. So to determine v1, we take parameters of motion around this place, where we have our u to be 0. So let's pick that. We have our u to be 0. Then we have our final velocity, our v, to be v1. Then we have our a to be 6. And then we have our t to be 20. That is, from here to here is 26. Using equation of motion, where we have v equals to u plus at. So let's find our v1. So definitely v1 equals to u, and u is 0 plus at, and a is 6 and t is 20. Then our v1 is going to be 0 plus, then 6 times 20 is going to give me 120 meter per seconds. All right, so this first velocity attained by this body is 120 meter per second. So let's put it there. So we can rewrite and put here to be 120 meter per seconds. So that's our v1, to be 120 meter per seconds. All right, please try to follow this class. Now the next thing is, we now want to look at what is the final velocity. So the body now starts during the second acceleration. When the acceleration is reduced, then the body starts from 120, then it reduces acceleration till it attain another certain velocity. So in this place, we are going to take another equation of motion around this, whereby this one now becomes our u, this one becomes our final v, and this one becomes our acceleration, and where our time becomes 10. So let's take parameters of motion around there, then we are going to get our final velocity. So let me clean this part, and then so that we can analyze that further. So now our u becomes 120, because the body starts from here now, because before it attains final velocity, it starts from here. So our u now becomes this. Then our v, our final velocity, becomes our v2 now that we are looking for. Then the next thing is that we have our a, acceleration is 4, and our time now, acceleration is 4, then our time now is 10. So let's apply equation of motion at this point too. In doing that, we are still going to say v equals to u plus at. And what's our v? Our v is our v2 now. Our u is now 120 plus at. Our a is 4 and time is 10. So our v2 is going to be 120 plus 40. So definitely our v2 is going to be 160, all right, meter per second. So the maximum velocity attained by this body, which is our v2 here, you can clean this one also and put it there. So our maximum velocity now is 160 meter per second. You discover that the object starts from 0 during the first acceleration. It attains a velocity of 120, and when the acceleration is reduced to 4 meter per second square, then it attains another velocity of 160 meter per second, which is now maintained for the next 30 seconds. So let's look at the next question now. The next question is now to calculate the total distance traveled during the first 30 seconds. The total distance traveled during the first 30 seconds. And we look at it, the first 30 seconds is from here to here to here. So from here to here is 20, from here to here is 10. So the first 30 seconds is from here to here. And if we want to take this graph, because distance is talking about area under the graph. So when you look at this point, you discover that this is not a particular graph. We cannot call this a trapezium, because this line and these lines are not parallel. So this does not have a particular shape. So what we're going to do to determine the distance covered for the first 30 seconds is to split these charts, this here, this 30 seconds here, I'm trying to go into two. So we are going to have two things now. We are going to have first a triangle, and then the second we are going to have a trapezium. Look at this. This is a trapezium now. This is the parallel side. This is the parallel side of the trapezium, and this is the height of the trapezium. All right, let me just bring the two diagrams out here, and then you're going to analyze how we are going to find the distance covered for the first 30 seconds. Okay, let's look at that trapezium now. You discover that now this is the first triangle. It's here now. I brought this triangle out to look at it. From here to here is 20. You see 20. From here to here is 10. It's 120. That is 120. And from here to here is 6. That's the first triangle. And the second one, look at it from here to here. It's from here to here like this. That is 120 also. From here to here is 160. You see 160. If I trace it down here, I'm going to see that it is 160. And from here to here is 10. You see 10. So looking at it now, for the first 30 seconds, we are going to have two shapes, a triangle and a trapezium. So to determine the distance covered during the first 30 seconds, we simply do that by finding the area of this triangle and adding it up to the area of this trapezium. So adding these two areas together is going to give our result. So let's look at the area of a triangle. Remember, triangle is half base times height. While area of a trapezium, S is 1 over 2 into bracket A plus B close bracket H. So let's substitute the parameters now and get our result. So we are going to have S equals to 1 over 2 into bracket. What's the base here? The base here is 20 and the height here is 120. Y here, S here, for here, okay, let's do it one after the other. For here, because of the space here, okay, let's shift the board. So let's look at this one. Is going to be here is this parallel side. Remember I said the parallel sides are the A and B. So this place is the A, this is the B. So the A here is 120. See 120 from here to here is 120. So you have 120 and plus B. B is 160. And close the bracket, and what is the H? The H is the vertical distance between the two parallel sides, which is 10. Alright, let's now solve further now. If I use my calculator straightforward to get the final result, so I'm going to get 20 multiplied by 120. That one will give me 2,400. And if I divide 2,400 by 2, so for this triangle, I'm going to have 1,200 here. Then let me add it to this side too. If I had 120 plus if I had 120 plus 160, it's going to give me 280. If I multiply that 280 by 10, it's going to give me 2,800. And if I divide that by 2, I'm going to have 1,400. So for this triangle, the area here is 1,200, while the area here is 1,400. So the total distance covered S, which is total distance covered, is not the summation of these two. So by the time I add it together, so I'm going to have 2,600 meter. So that's how we determine the distance covered by that body. So the next thing is we want to look at the average speed now. Average speed. Okay, to determine the average speed during the same time interval, that is for the same 30 seconds. I remember that our distance for that time is 2,600 meter. And what's our time? Our time is 30 seconds. So we can simply find our average speed by saying V is distance over time. By doing that, we are going to have 2,600 divided by 30. And if we press our calculator to find that, we are going to have like 86.7 approximated time. Okay, yes, velocity, meter per seconds. That's how we solve these particular questions. So I believe you understood this particular question, so you can just go over it and to study the question again. So kindly like this video, comment. If you have any question, you can just comment in this section, and like this video and subscribe to this channel. Thanks for watching this video, and God bless you.